Okay, so in this lesson, we will learn about adding and subtracting like fractions. This is chapter 4, lesson 3. Okay, so the objective of this lesson is at the end of this lesson, we should be able to add and subtract like fractions. Brings us back to the essential question, what happens when you add, subtract, multiply, and divide fractions? The last lesson, we compared and ordered decimals and fractions. This time, we are going to learn how to add like fractions. The vocabulary we need to learn right now would be like fractions. What are like fractions? Okay, so let's go jump into the key concept right now. And it's saying that to be able to add like fractions, okay, add or subtract the numerators and write the result over the denominator. What does that mean? So when you have this problem right here, 5 tenths plus 2 tenths, you notice that they have the same denominator. So all you need to do is keep the denominator and simply add the numerators 5 plus 2. We know that 5 plus 2 is equal to 7 over 10. So it's the same way with 11 over 12 minus 4 over 12. Again, denominators are the same. We keep the denominators and we simply subtract 11 minus 4. That gives us 7 over 12. In algebra, okay, instead of numbers, we are using letters. We have a over c plus b over c. Again, we have the same denominator, so we keep that denominator. And we simply add the numerator a and b. So we have a plus b over c, where c is not equal to 0. And in subtraction is the same way. We have the same denominator, so we keep the denominator c, and we simply subtract, okay, a and b. So the answer is a minus b over c, where c is not equal to 0. This condition tells us uh, that c should not be equal to 0 because you cannot divide anything by 0. And that's the reason why your denominator should not be equal to 0. If the denominator is equal to 0, the number would be undefined. So we talked about common denominators, and what do you call fractions with common denominators or the same denominator? So we now go to the definition of like fractions. So fractions that have the same denominators are called like fractions. And that's the reason why you see here 5 tenths and 2 tenths are like fractions. 11 twelfths and 4 twelfths are like fractions. Same thing in algebra, a over c and b over c are also like fractions. Take a look at how this works. Example number 1, we have 5 ninths plus 2 over 9. So we know that they are like fractions because they have the same denominator. So we copy the problem down and we keep the denominator the same. And we simply add 5 plus 2 together gives us 7 over 9. So the answer is 7 over 9. On the right side is just a visual representation of 5 ninths plus 2 over 9. Okay, this proves why 5 ninths plus 2 over 9 equals 7 over 9. Because if you start with 0 and go to 5 over 9, this is a vertical number 9. So 1 ninths, 2 ninths, 3 ninths, all the way to 8 ninths. And 9 over 9, which is equal to 1. So 5 ninths is here. And if I add 2 ninths, it ends up in 7 over 9. So this also proves why 5 ninths plus 2 ninths is equal to 7 over 9 using a number line. So in this problem, we're adding negatives. Okay, we have negative 3/5 plus negative 1/5. Okay, again, what we know that the fractions are, okay, like fractions because they have the same denominator. Okay, now since these are negatives, look what happens. The negative sign goes to 3, the negative sign goes to 1. So now you have negative 3 and negative 1. So you have negative 3 over 5 plus negative 1 over 5. We keep the denominator the same, which is 5, and simply add negative 3 plus negative 1. Negative 3 plus negative 1, according to our rules of integers, is negative 4. So negative 3 plus negative 1 is equal to negative 4, and that's how you got negative 4 over Okay, now, okay, one last step. We move that negative sign down here, and that's the reason why you have this. Put the negative sign in the middle once you have arrived at your answer. Okay, do the guided problems, and let's see if you understand adding fractions with like denominators. Example number 3, you have Sophia ate 3/5 of the cheese pizza, Jack ate 1/5 of the cheese pizza, and 2/5 of the pepperoni pizza. How much pizza did Sophia and Jack eat? So if you look at this problem, the word altogether, okay, tells us that we need to add them. So we have 3/5, which is the amount Sophia ate, 1/5 and 2/5, which is the amount that Jack ate, 1/5 of the cheese pizza, and 2/5 of the pepperoni pizza. Okay, using the commutative property states that we just have to move the numbers around. We simply move 2/5 here and 1/5 over there, and that's the reason why you have this. So we move this here and we move that there. Using the commutative property, we end up with 3/5 plus 2/5 plus 1/5. Using the associative property, we simply group 3/5 and 2/5 together right here. And the reason we do that is because we know that 3/5 plus 2/5 is easy to add. Because 3/5 plus 2/5, since they are like fractions, we keep the denominator the same. 3 plus 2 is 5. So we know that 5 over 5 is also equal to 1, which is there. And we add 1 plus 1/5, becomes 1 and 1/5. Okay, so Sophia and Jack ate 1 and 1/5 pizzas all together. Okay, do the guided problem. Let's see if you understand that word problem. Example number 4, we are now dealing with subtraction. We have negative 5/8 minus 3/8. Okay, again, we know that they are like fractions because they have the same denominator. So what we need to do is simply keep the denominator. Okay, and remember when we're doing subtraction, when you subtract, you're adding its opposite, and that's the reason why you have it here. So let's see, let's rewrite this here, negative 5/8 minus 3/8. Using what we know about adding and subtracting integers, we bring this down, negative 5/8. And when subtracting, you're adding its opposite. So you're adding the opposite of 3/8, which is negative 3/8. And that's why you have this expression right there. Okay, now we're back to addition. So we keep the denominator the same, and we simply add negative 5 plus negative 3. We know that negative 5 plus negative 3 is negative 8 over 8. So this is negative 8 over 8. Or put the negative in the middle, it's still negative 8 over 8. And we know that negative 8 over 8 is the same as negative 1. Okay? Example number 5. 5/8 minus 7/8. Okay? Again, we know that they are like fractions because they have the same denominator. So we keep that denominator and we simply subtract, okay, 5 minus 7. So from what we learned, 5 minus 7, again, when subtracting, you're adding its opposite. So bring down the 5. You're adding the opposite of 7, which is negative 7. Okay, so we know that 5 minus 7 is also negative 2. And that's the reason why this becomes negative 2 over 8. And the simplest form of negative 2 over 8 is negative 1/4. Why? Because if we have negative 2 over 8, we divide that with a GCF, which is 2. The greatest common factor of 2 and 8 is 2. And 2 divided by 2 is 1. And negative 8 divided by 2 is also 4. So you have negative 1/4, which is that answer right there. Okay? Do the guided problems. Let's see what you've learned. Finally, in the last example, which is a word problem, about 1/6 of the population in the United States lives in Florida, and about 4/100 lives in Ohio. So the question is asking about what fraction more of the US population lives in Florida than Ohio. The word what fraction more tells us that we need to subtract. Okay, so we get the population in Florida, which is 6/100, subtract the population in Ohio, which is 4/100. So now we have 6 minus 4/100. We keep the denominators the same, and we simply subtract 6 minus 4, which gives us 2/100. Simplest form is 1/50. Why? Because we have 2/100. The greatest common factor of 2 and 100 will be 2. So 2 divided by 2 is 1. 100 divided by 2 is 50. That's how we got that answer. So therefore, about 1/50th more of the population lives in Florida than in Ohio. Okay, thank you for watching, and that's the end of our lesson.